Good morning. Hopefully you've been enjoying a number of sessions this morning. I do realise that this is probably the last session before standing between you and lunch, so we'll crack on. We have two gentlemen here who are going to be telling us how Swisscom have provided MongoDB Enterprise in self-service and at scale leveraging Kubernetes Operator. Both individuals are technology enthusiasts. One individual, Joel, is experienced in infrastructure automation, software-defined networking, and highly available databases. He is CKAA and CKAD certified and written several CRD operator-based Kubernetes extensions. Adrian is the author of open source BOSH release of MongoDB Enterprise and a contributor to Open Service Broker, and is a cloud-native enthusiast. In this session, they'll be telling you their experiences of building MongoDB-as-a-Service, operating hundreds of clusters for various use cases, and looking at that journey from virtual machines to Kubernetes. Please give a round of welcome to Joel Studler and Adrian Kurtz.
Thank you very much. So please raise your hand if you've ever deployed MongoDB on Kubernetes. Ooh, that's a few hands. I expected a bit more. How did you feel? Was it easy? Raise your hand if you feel that was easy. Oh, that's even fewer. Okay, so seems that that's not so easy. Today we're going to talk about our journey with MongoDB as a service in our cloud, and kind of what our experience was with deploying MongoDB on Kubernetes. Who are we? My name is Adrian Kurt. I am a product owner at Swisscom Cloud.
And I'm Joel Studler. I'm DevOps engineer and systems architect at Swisscom. Very warm welcome from my side. Thanks for being here. Thanks for taking time. Thanks MongoDB World for having us. So as said, we both work for Swisscom. Swisscom is the biggest telco provider in Switzerland and one of the major IT services providers. You may know Switzerland from its famous chocolate and banks. That's not the only thing we do. We're also great in engineering, which is proven by products like the Swiss Army knife or more modern products like Doodle. We are great at privacy. We enable companies like ProtonMail to secure their users' emails in a very, very private way. And last but not least, and a little off topic, we're also good in design. We have a long history in design. For instance, the New York City subway still uses a Swiss font for their signaling. But that's enough about Switzerland, I guess. Let's jump into it. Today we're going to start with providing some information about Swisscom private clouds. We're then going to take you on a journey on our MongoDB experience on Kubernetes by showing the evolution of our MongoDB service in its various iterations. And eventually we're going to land on our experience with MongoDB Enterprise Kubernetes. And at the very end of our talk, we're going to share our proposed best practices regarding MongoDB on Kubernetes.
So let's shortly start with private cloud. What were we doing at Swisscom? Joel also said we're a large company. We particularly are working in kind of the area of IT services. We do provide private cloud services to our customers. We have there kind of two segments. We have small and medium enterprises as well as large enterprises. Typically, these customers have rather high regulated workload, a lot of compliance needs, and then they opt for Swisscom's private cloud services. We offer infrastructure as a service, rather classical. We offer container as a service, obviously the Kubernetes that everybody needs today and wants today. But we also have platform as a service based on Cloud Foundry. That's actually where we both are working on in our daily life, and that's what we want to focus on. So in our platform as a service that's based on Cloud Foundry, we have a lot of database services. I'm not sure if you're familiar with platform as a service. Typically, you have there your 12-factor apps. So these are web applications that are stateless. And because the application itself is stateless, you do need stateful services. And that's currently our range that we offer. We have MongoDB, Redis, RabbitMQ, MariaDB, Elasticsearch, and S3 in our services portfolio. And obviously today we are going to talk about MongoDB. So back in like 6 years ago, we started with that whole journey, and we started to build our first MongoDB service. It was very simple. We started with 3 VMs. Back in the day, we could already leverage Ops Manager. So we had an Ops Manager running next to it, installed the MongoDB agents on top, connected it to Ops Manager, and then you can easily deploy and configure MongoDB instances on top of each VM and configure them to be a replica set. Oops. At the bottom you see we have our 12-factor application from Cloud Foundry that easily then connects to all of the VMs, and everybody's happy, right? You have your MongoDB as backend. That service was launched back in 2016. It was fully end-to-end, or is still fully end-to-end provisioning, automated, sorry. It has a 3-node replica set as a standard deployment, so we always go for high availability. You can have it in different sizes, so RAM, CPU, storage configuration. Provisioning typically takes between 10 and 15 minutes. That is kind of dependent on how fast the VMs spin up, and it's fully based on free and open software. So as mentioned in the introduction, we have the open service broker, which is kind of the orchestrator, and we use Bosch for kind of the orchestration of VMs. So that's available on GitHub at the Swisscom org if you want to have a look. One of our most prominent cases that uses this service is MyCloud. MyCloud is kind of Switzerland's answer to something like Google Drive, Dropbox, as well as Google Photos. It has these 2 functionalities. You can easily back up your photos, and also you can synchronize and share data. All this data resides within Swisscom's data center in Switzerland, and you can profit from all our kind of heavy laws on privacy and data security. So while this was a really nice service and we had a lot of customers using it, we thought about switching to Kubernetes, and kind of the reasons here are people demanded for smaller plans, so kind of have even smaller instances of MongoDB available for development purposes, or maybe they just didn't use that much storage or RAM. Then we wanted to speed up provisioning time. Waiting 10 to 15 minutes is not really cool if you fully automate your deployments. We wanted to reduce overhead, and we generally wanted to reduce prices even further so our customers could buy more at a cheaper rate. So that's kind of when we thought about moving towards Kubernetes as our first evolution of the service. And with our Kubernetes service, we achieved quite a lot of these things. It was launched in 2017, so very early in the stage of the Kubernetes project, actually. It was built on our own Kubernetes distribution. We had clusters that were running over 300 nodes, so these were really large Kubernetes clusters. We had multiple thousands of pods running on there. And provisioning time was really slow, really fast. It was like less than 5 minutes typically. And we could reduce our production costs. Let's have a look on how that was built. So typically, if you build a Kubernetes, you start with 3 zones within 3 different availability zones. For us, that's even in 3 different data centers located across Switzerland. You then deploy your API nodes and worker nodes of Kubernetes. That's just standard Kubernetes, nothing fancy yet. And then typically you would start to deploy your MongoDB. Here as well, we start with 3 instances or 3 MongoDBs and wanted to kind of connect them as a replica set. What you typically do is you leverage the pod network and connect the replica set over that one. Then as the next step, you have your 12-factor application, right, as kind of the user of that database, and you would just create a Kubernetes service and connect to that MongoDB replica set. The experienced people here realized that won't work, right? It's not working with a regular service. MongoDB does or did not support NAT back in the day. Remember, that was 2017. You have to use the same addresses within the cluster as well as you use them from the outside. So the MongoDB driver is actually receiving all the cluster information as a part of the service discovery mechanism. And it wouldn't work because the addresses are different inside the cluster than outside the cluster. So what we do, we need to take a step back and think about how can we achieve that we have the same addresses from outside the cluster so the 12-factor application can reach it, as well as from the inside. And what we did back in the day was we used node ports. So the MongoDBs are exposed on the node network, which is the same network that also the 12-factor application can reach. And through that, we could actually achieve our service. Was quite nice, had a couple of workarounds, as you see. That was the second iteration of our service.
So let's have a look at Kubernetes operators at this time. What is an operator? It's basically an extension of the Kubernetes API. So Kubernetes is very extensible by design. So you add a custom resource definition, which is basically the schema of your API. And then you can instantiate these definitions by using custom resources. That's basically the Kube API part of it. And then you add your business logic as an operator. So your operator will run the business logic you want it to. Could be lifecycle topics, could be backup, self-healing, or whatever you like it to do. Why should we use Kubernetes operators? I think the first reason is very clear. Kubernetes is well established. It's the de facto standard for container orchestration. DevOps engineers around the world, they know tools like kubectl or Argo CD. They're familiar with them. So know-how is there. The second reason we think is the reconcile loop. That's the basic pattern how an operator is built. So it's really observing the current state, it's diffing it with the desired state, and then taking action based on the differences. And that's the loop an operator is in, like endlessly, basically. And the third reason is clearly the vivid community of Kubernetes itself, or KubeBuilder, the framework that is most commonly used for building operators. So how do you build operators? Basically, you download the KubeBuilder binary, generate your boilerplate code using a one-liner, and then you're ready to go and write your business logic in Golang, as KubeBuilder is built for Golang programs. And then if you've tested and built it successfully, you can run it on your Kubernetes cluster. So a side note here, you can basically use whatever language you prefer. KubeBuilder itself is limited to Go, and KubeBuilder is the most popular framework. So now we know how to build an operator. We know we should use Kubernetes because everyone is asking for it. Companies are asked by their customers, is your product compatible with Kubernetes? Does it run on Kubernetes? Does it scale and whatever? But the big question now is for the company, like MongoDB, for instance, is how do you achieve Kubernetes mastery? How do you master Kubernetes as a whole for your product? That's why I put the little crown on there. So we've seen two different approaches. The first approach is really to start Kubernetes native, use CRDs, use operators right from the start, and then you add your features later. We call this the Kubernetes first approach with Kubernetes in mind at the very beginning. That's very good for greenfield product development, not so easy for legacy product, let's say. So the advantage you have is you have Kubernetes nativeness from the very start, but not all the features you have in your, let's call it, legacy product, and you will add features later in the process. The second approach is basically containerizing the existing application and make it Kubernetes native in a later stage. We call this the features first approach. The advantage there obviously is that you will have all the features at the very beginning, but it's not as Kubernetes native as you might wish, or as DevOps engineer might wish. Two examples. For the Kubernetes first approach, we clearly see the MongoDB community operator, which is built with CRDs and operators right from the start. On the other side, we have the MongoDB Enterprise Kubernetes operator, which containerizes the Ops Manager application and ports it to Kubernetes, but it's not really Kubernetes native. There has to be some interaction between Ops Manager and the operator.
So why did we switch to the Kubernetes operator in the end? It was mainly to reduce our maintenance efforts. You saw earlier, I've told you we maintained our own Kubernetes cluster, we maintained the whole logic on top, we maintained that ourselves, and with an operator you can just basically get that for free. It also adds additional enterprise features which we never built, and it adds proper support from MongoDB, so we have the backing of MongoDB with that service. Back in the day, we also had that switch from Apache 2 to SSPL, so there was a topic around license conformity. And Joel just mentioned the reconciliation loop is a really mighty tool to actually ensure that stuff is running all the time. So we started to collaborate with MongoDB. It started back in 2020. We met with the product management team of MongoDB and discussed about the MongoDB Enterprise Kubernetes Operator. Together, we've filed about a bit more than 50 feature requests and bug reports, and over 30 of them are successfully implemented or fixed by now. And all in all, we had a bit more than 20 syncs until now. So you see, we had quite the collaboration.
Let's have a look at our experience with MongoDB Enterprise. So that's really the next iteration after our self-developed Kubernetes-based MongoDB product. We're going to show you 3 examples of what gaps we've seen and how we fixed them. The first one is asset delivery. So the problem is clearly how do you deliver all the assets that Ops Manager needs in an offline environment that doesn't have any internet access. So there are 2 types of assets. The first one is the version manifest, which basically contains version information, file names, and so on. This file needs to be pushed to the Ops Manager API. The second item are the MongoDB binaries, which are in a tarball and need to be copied into the file system of Ops Manager. So how did we solve this? Maybe one small side note here is that I think newer versions of Ops Manager solve parts of these problems already. As we are still using MongoDB Ops Manager 4.4 in some environments, we still rely on this solution here. So we have a CI job that basically downloads the binaries and manifests from MongoDB.com, builds them into an OCI image, and pushes them to a public OCI registry. We then have this internet access gap in the middle. Everything on the right side doesn't have any internet access. It's most likely an enterprise scenario like a bank or insurances that don't want to have internet connectivity. We have a second CI job there that scans the image, and if there are no unknown vulnerabilities, it will mirror it to the internal OCI registry where it can be reached by the Kubernetes cluster. So in this case, we now have two types of jobs. One is the init container of Ops Manager, which runs this image and copies the file into the file system. The second one is the job on the left side, which pushes the manifest file to the Ops Manager API. So that's how we work around the current limitation of offline availability for Ops Manager. So the second example is end-to-end automation. We think as Ops Manager is not a Kubernetes native tool, there are some automation gaps, some things that cannot be automated from Kubernetes. The main reason, I think, is because Ops Manager has its own identity and tenancy management, which the operator needs to authenticate with. That's, I think, the basic reason. So what we've seen is when you try to deploy a MongoDB cluster from Kubernetes, you need to start by doing some manual interaction with both Kubernetes and Ops Manager. So the first step is you create an organization, then you generate API keys, then you create a Kubernetes config map that references your organization and Ops Manager, and then you create a secret with the generated API keys, and only then you will be able to actually deploy your MongoDB instance. So from our point of view, that's too many manual steps because we want to have end-to-end automation. So we came up with the solution to basically map Kubernetes namespaces to Ops Manager organizations. So for each Kubernetes namespace that holds a MongoDB instance in it, there will be an Ops Manager organization created. And we did that using a self-developed operator. So we call this the MongoDB Enterprise Complement Operator because it adds functionality and it coexists with the existing MongoDB Enterprise Operator. So we reuse the same CRs, same CRDs, and we just add the functionality with what we need. And this helps us achieve end-to-end automation and a zero-touch experience for the user. We're well aware that the one-to-one mapping between namespace and organization doesn't fit every use case. That's just our implementation. And that's also why we think it's a good solution to add this functionality ourselves. So let's look at it shortly. This is a little demo of what this looks like. So on the bottom left, you will see the tailed logs in a pretty print format of our operator. On the right side, you will see the list of the organizations in Ops Manager. And on the top left, you will see some Kubernetes interaction that shows the creation of the organization. So when we create a namespace, basically nothing will happen because there's no MongoDB instance in it. We can see it's reconciling, but nothing happens in Ops Manager. When we now apply this MongoDB custom resource, which is a standard MongoDB instance, when we apply this to the namespace, we can see there's a lot of stuff going on the operator side, and in Ops Manager, we can already see the organization created. There's no project yet because the MongoDB Enterprise Operator will need to catch up and create the project. So that the project was there, it was just a short time, is kind of proof that the authentication worked for the operator. So let's delete the MongoDB instance again because we don't need to demo how to create a MongoDB cluster. You can do that yourself if you're interested. Let's have a look at the namespace. We can see there's a finalizer which basically prevents that it's a Kubernetes concept to prevent resources from being deleted. So this finalizer basically prevents the namespace from being deleted before the organization is removed. So we can see the organization is already gone as we deleted the namespace, and the namespace is also removed. So we have a full creation and deletion of the organization. The third use case is AppDB backup. So Ops Manager has its database, which is called AppDB, which is a standard replica set. And we have a kind of a chicken-egg problem because Ops Manager cannot back up its own database because this exact database holds valuable information about references to S3 blobs. So if we lose that database, there's no way for restoring it. So that's something that's going to be resolved by the Ops Manager product, but it's not yet resolved. The supported solution would be to add a second Ops Manager instance and back up your actual database with that Ops Manager instance, which is way too heavy for us, way too much overhead. The solution we came up with is Velero with MongoDump. That's our intermediate solution until the backup is fixed in the product. So what does this look like? On the bottom, we have our 3-node replica set, which is the AppDB. On the top, we have a stateful set, which executes a MongoDump using Velero hooks, and then backs up, basically stores the MongoDump on an empty dir volume. So Velero can then take this MongoDump and put it into an S3 bucket, basically. In Kubernetes YAML, this looks something like what you see on the screen. It's very simplified. We have our stateful set. With Velero, everything works with annotations. So the first annotation will be which volume to back up. So this would be our empty dir volume we've seen earlier. Then we have a pre-backup hook, which is executed before the backup is taken by Velero. So there you can put any command you wish. In our case, that's a MongoDump that dumps the database to a specific path in the file system. And then we have a post-backup hook, which removes the file again after we perform the backup. So this is a little demo of a backup being taken by Velero. If we look at the stateful sets, we can see the Ops Manager database, which is our AppDB, and the backup stateful set. We can have a look at the Velero backups. We see there is one successful backup. And when we look at the logs of the backup pod, we can see at the very beginning that a MongoDump is starting, and at the very end, we can see that it's finished properly. And we can see that the file on the file system is also removed. So we can see pre-hook and post-hook are executed as expected. We can also have a look at the Velero backup to show a little more detail about which namespaces were backed up, how long it took, and so on. There's a little disclaimer to that. So you might see side effects if you restore a backup or an AppDB that is backed up that way, because S3 and your actual database won't be in sync, so you might have to resync your backups, or you might end up having orphaned S3 objects, which is not nice, but it's not a big deal, basically. We still recommend you to take offline backups, so please shut down your Ops Manager when you do lifecycle in Ops Manager. Shut it down, take a backup, do the official proper way, because the way we did just show you is not officially supported by MongoDB, and it's just our latest fail-safe for disaster recovery.
So that already concludes our talk with, or I will already conclude our talk with our best practices. We've collected a couple of things for you to take away. Let's start with the things you should avoid. So we recommend that you avoid building your own Kubernetes. I've told you we did that. It's a lot of effort. There is not that much benefit out of that. And we also recommend that you avoid building workarounds like the story I've told you about these network troubles we had with the Kubernetes service in version 2. We recommend that you do embrace cloud-native technologies, leverage that vivid community. It has a lot of concepts, a lot of know-how. There's so much things already there you can just use and kind of start. Do not do the same mistakes other people did. Extend solutions in a non-interfering way. Joel told you about our complement operator. It's a really nice example how you can add your own functionality without interfering with the base product. Please contribute back to the community as well. And last but not least is contact your vendor or the creator of the software, talk to them, discuss with them what your demand is. I've told you with MongoDB, we've resolved over 30 issues. And back in the day when we started in 2020, it was not fitting our use case at all. And now we have a really nice product. It works end-to-end very nicely with the couple of additions we did.
So with this, we encourage you to get started now. Start using the operators community or enterprise, or the Atlas operator as well that has been GA'd yesterday. Please write your own operator if you see fit. There are use cases where it makes sense. And don't hesitate to get in touch with us. And with this, we thank you very much for listening. I'm not sure if there's time left for some Q&A.
I think we've got probably just time for one single question if anyone has a question. I do have one myself if not. Oh, no, you have got one, so 1 second.
Hello. This is a question about the Kubernetes deployment that you guys had. You mentioned that you were able to deploy it in a multiple data center. So did you have a stretched cube cluster, or did you have a 3 different cube cluster and managing your individual replica set nodes differently?
It's one cube cluster stretched across 3 data centers. If you know Switzerland, it's a rather small country. So we don't have latency problems between our data centers. We do have, as we are a network company, we do have really good connectivity between our data centers. So that's not a problem. You can easily kind of distribute that in Switzerland. I don't know by heart what the latency between the data centers is.
I think it's below 2 milliseconds.
Yeah. It's really low. As I said, it's a small country. It's basically a bit of fiber in between, and that's it.